Imagine floating weightlessly above Earth. No sound, no air, just the black void of space stretching endlessly around you. Then suddenly, disaster strikes. Your suit is punctured. Oxygen begins to hiss out. And before you can react, you're exposed. No helmet. No protection. Just you, and the vacuum of space. Most people think you'd explode instantly, or freeze solid in seconds. But the truth? It's far more terrifying, and far more real. Because what actually happens to a human body in space isn't what you've seen in the movies. It's worse. And today, we're going to take you through those 10 seconds. Second by second. Step by step. From the inside out. The vacuum of space isn't just empty. It's hostile. There's no atmosphere, no air pressure, no oxygen, and extreme temperatures that range from blistering hot to freezing cold depending on exposure to the sun. But more than anything, space is unforgiving. And the human body? It's designed for Earth. Our lungs, our blood, our skin, they all depend on pressure and oxygen to function. Remove those two things, and the body begins to fail. Fast. Let's start with second one. The moment your body is exposed to space, you don't explode. You don't instantly freeze. But you do begin to die. The very first thing that happens is panic. You try to hold your breath instinctively, but that's the worst thing you could do. In a vacuum, holding your breath causes the air inside your lungs to expand uncontrollably. And because there's no external pressure, your lungs can actually rupture. The best thing to do, ironically, is to exhale. Completely. Let the air out. Because trying to keep it in will kill you even faster. By the second, oxygen has completely disappeared from your lungs and bloodstream. Hypoxia sets in, oxygen starvation. Your brain cells are still alive, but they're beginning to panic. You feel lightheaded. Your vision narrows. You can't scream, because there's no air to push through your vocal cords. Everything around you is dead silent. Not quiet, silent. And that silence is absolute. At second 3, you lose consciousness. Not from the vacuum itself, but from the lack of oxygen. It's similar to fainting, except far more dangerous. In fact, NASA has data from real-life incidents where test pilots and astronauts lost pressure in high-altitude training. In most of those cases, they blacked out within 10 to 15 seconds. So 3 seconds in space? That's enough to knock you out cold. But the body doesn't stop reacting. At second 4, your skin begins to swell. Your blood doesn't boil in the way Hollywood suggests, but because of the pressure drop, gases inside your body expand. Your face puffs up. Your eyes bulge slightly. You don't explode, but your body looks off. Puffy. Distorted. And here's the scariest part. If you were somehow watching yourself from the outside, it would look like you're inflating like a balloon. By second 5, moisture in your mouth, nose, and eyes begins to evaporate. Saliva starts to boil off your tongue, not because it's hot, but because the boiling point of liquids drops dramatically in a vacuum. That means your mouth dries out in an instant. Your tongue cracks. Your eyes feel like they're burning. And all the while, you're unconscious. You can't even scream. At second 6, your circulatory system is still pumping, but it's failing. The lack of oxygen has made your heart work harder, but there's no oxygen to deliver. Your blood vessels are dilating uncontrollably. Your brain, already shut down, is beginning to suffer permanent damage. If someone doesn't rescue you in the next few seconds, your body won't recover. At second 7, UV radiation from the sun is hitting your skin full force. There's no ozone layer, no atmosphere, nothing to protect you. That means the radiation is cooking your cells. Severe sunburn, DNA damage, possibly cancer, if you survive. If you don't, it won't matter. By second 8, ice crystals may begin to form in your exposed tissues. Not all over your body, you don't freeze solid instantly. But places like your mouth and nostrils begin to show signs of freezing. The moisture there is gone. And what's left? Frost. In the middle of the vacuum. At second 9, neurological failure begins. Your brain, already deprived of oxygen for nearly 10 seconds, starts to suffer irreversible damage. Even if you're rescued now, you may never wake up. Or if you do, you won't be the same. Motor functions, memory, personality, everything could be altered. And then finally, second 10. Your body is still mostly intact. You're not shattered, you're not frozen into a block. But make no mistake, you're dead, or as close to death as possible. After 10 seconds of exposure, your brain is damaged, your organs are failing, and your blood chemistry is in chaos. If someone were to drag you back into a pressurized cabin right now, there's a slim, very slim chance you could be revived with intensive medical care. But most wouldn't make it. 10 seconds is all it takes to cross the line. But here's something even more fascinating. NASA has studied near-vacuum exposure in both animals and humans, mostly during accidents, and the findings are chilling. In one 1965 incident, a technician in a vacuum chamber suit lost pressure. He was exposed to near vacuum for 12 to 15 seconds before being repressurized. He said he felt saliva boiling off his tongue. He lost consciousness at around 14 seconds, and survived, but only because he was rescued immediately. That's how precise the timeline is. Just seconds make the difference between survival and death. So what can we learn from this? That space is not just cold and vast, it's violently indifferent. It's not there to kill you, but it will. Instantly. Without hesitation. Without warning. The only thing between life and death out there is a few millimeters of fabric and metal. A thin layer of technology separating us from oblivion. And this brings us to the deeper question. Why do we, as humans, keep going back? Why do we risk our lives to explore something so dangerous, so hostile, so merciless? Maybe it's because space, for all its darkness, offers something no place on Earth can. The unknown. The frontier. The chance to see something no one has ever seen. To go where no one has ever gone. And that desire, that hunger for discovery, might just be stronger than fear itself. If you've made it this far, you're probably like us, fascinated by what lies beyond our planet. So take a second, subscribe to the channel, and hit that notification bell so you don't miss what's coming next. Because space? Space is just the beginning. And we're going deeper.